Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm your teacher, Mamu, and I will teach you mathematics. All right. So in our previous lesson, we have seen the third unit of grade 8 mathematics, which is about linear equations and inequalities. And we have seen the first part of the third unit, which was about the Cartesian coordinate system. All right. Do you remember what the Cartesian coordinate system is? A Cartesian coordinate system is a system which is obtained by intersecting two axes, which is the x-axis and the y-axis, okay? So the x-axis and the y-axis together forms a Cartesian coordinate system, and the point where these two axes intersect is called origin, okay? Its coordinate is 0, 0. Good. So in our discussion that we had in our previous lesson, we have also seen the 4 quadrants, right? We have seen the 4 quadrants. Say the vertical line is the y-axis and the horizontal line is the x-axis. Okay, so the vertical axis or the vertical line is the y-axis, and the horizontal line is the x-axis, and the point where these 2 points or where these 2 lines intersect is called the origin. Usually this point is 0, 0, okay? So as you can see here, these 2 axes forms 4 different regions, okay? This is called first quadrant. This is a second quadrant. This is a third. And this is a fourth quadrant, all right? So having these quadrants, we have also seen the nature of the points in each quadrant, okay? Do you remember the nature of the order pairs in the first quadrant? Good. If you take a certain point, say the point is containing 2, 3, if we have an order pair containing 2, 3, where do you think these 2, 3 is found? Is it in the first quadrant, second quadrant, third, or fourth? Well, this point is found in the first quadrant. Do you remember how we did this thing? 2, 3 means 2 is the value of x. So since 2 is positive, you need to move 2 units on the right side of the y-axis. So you can roughly cut out the lines into pieces, 1, 2, 3. Then you have to move 2 units on the x-axis. Then 3 units above the above the x-axis. So roughly 2, 3 is found in the first quadrant around here, okay? So this is roughly the point where point A is found, okay? Generally, any point in the first quadrant have this property. The first entry positive and the second entry positive, right? So generally, we concluded that if we have a certain point x, y, this x, y is in the first quadrant if it possesses this property. Both x and y are positive number or greater than 0, right? So this is the characteristics of points in the first quadrant. What if the point is, say the point is with entry minus 2, 3? Where do you think this point is located? Well, minus 2, 3 is a point in the second quadrant. So how do you locate this point in this Cartesian coordinate system? This is the procedure. The first entry is -2, so minus is found in the left side of the y-axis, so you need to count 1, 2, and so you need to move 2 units to the left of the y-axis. Then this is 3, which is positive, so you need to move upward 3 units from the x-axis. So roughly this point B is located in the second quadrant. This is how you sketch points in the Cartesian coordinate system. All right. The other case, if our point is a point with entry -2, -3, where do you think this point is located? -2, -3. This is a point where the two entries are negative. So this is the convention. The value of x is negative, therefore I have to move to the left of the y-axis by 2 units, right? So you need to count 2, then you stop it. Then the value of y, or the second entry, is negative. Therefore, you need to count 3 units downward, okay? So point C is located somewhere around here, okay? So point C is a third quadrant point, okay? Here, I want to tell you the characteristics of the point in the third quadrant. Look, here, this point is a third quadrant point. As you can see here, both the entries are negative. So you can say a point in the third quadrant have these characteristics, whereas a point in the second quadrant possesses these characteristics. X, y is a second quadrant point if the first entry is negative and the second entry is positive, right? So to add one more point regarding what we have seen in the previous lesson, let's take some other point D. Say point D is a point with entry +2, -3. Look, these all are points with different sign, right? So point D is a point where the first entry is positive and the second entry is negative. So here, X is +2, so you need to move 2 units to the right of the y-axis, and Y is negative, so you need to move 3 units downward, 3 units from the x-axis. So roughly, point D is located around here, okay? So a point D is, this point D is a point in the fourth quadrant. Generally speaking, any point X, Y in the fourth quadrant possesses this property. The first entry is positive, and the second entry is negative. So these all are the things that we have seen in our previous lesson, okay? So this is the characteristic of a point in the first quadrant. This is a second quadrant. This is a third. This one is a fourth quadrant, right? So knowing the location of the point in the Cartesian coordinate system is very important to understand the graph of a linear function, the graph of any function, which will be part of our today's discussion, okay? So today we will see 3.2, which is about graphs of linear function. You have learned about solving graphs of a linear equation in your previous grade level. Here, we will see how the graph of a linear function can be sketched, okay? So in this lesson, I will show you the two methods of sketching the graph of a linear function. The first method is, method one is using points, okay? Construct table of values. Okay, the first method that we use to sketch the graph of a linear function is construct table of values. We construct a table of values. How do we construct a table of values? We have 3 steps, okay? The first step is, in this method, the first step is taking 3 x values, okay? In step 1, we will take 3 different x values, okay? Take 3 x values. After we take 3 different x values, we substitute those x values to obtain the value of y, okay? Here, you need to know what a linear function looks like. A linear function is f of x is equals to ax plus b, where this a is a constant number different from 0, right? So once we have a linear function, we can take 3 different x values and obtain the corresponding y values. Okay, we take 3 x values and obtain the corresponding y values, because x and y are related in the form of function. Here f of x means y, and y is equals to x plus b. Okay, whenever you plug different x values here, you will get y values, because a and b are a certain known constant values. So for each of those 3 points of x, we will obtain a certain unique y values, right? So this is the first step. In the second step, is we plot the order pairs, which is obtained in the first step, okay? In the first step, you take 3 different x values and substitute in the equation to obtain the corresponding y values. So the second step will be, we plot those x comma y values. You will plot 3 order pairs in the xy plane, right? So this is the second step. The third step is we connect those 3 points and form a straight line, okay? The graph of any linear function is a straight line. So once you have these 3 points, you will connect those 3 points and form a straight line. That will be the graph of a linear function. So here I will show you some examples on how we can apply this method, okay? The first example, sketch the graph of y is equal to 2x plus 6. Okay, clearly this is a linear function. So to sketch this linear function, we will apply the steps that I explained in method 1. Okay, so the first step is, as I have told you, the first step is, or step 1 is, take 3 x values, right? say x is equals to 1, x is equal to minus 1, and x is equals to 0. Okay, take these 3x values. Okay, so you can simply construct a table of values containing these x and y, right? Say the first row contains x values and the second contains y values. So whenever x is minus 1, we will substitute minus 1 here and obtain the value of y, right? So whenever you substitute minus 1, the value of y becomes 2 times minus 1 plus 6. Okay, so this means minus 2 plus 6. Minus 2 plus 6 is positive 4. Okay, so whenever we substitute minus 1, the value of y becomes 4. Okay, take again x is equals to 0. Whenever x is 0, we will obtain a certain y values. So substitute x is equals to 0 in the function, then the result becomes 2 times 0 plus 6. Okay? 2 times 0 is 0, and 0 plus 6 is 6. So the value of y becomes 6 whenever x is 0. Okay, you put 6 here. Okay, the third point that we have taken here is x is equals to 1, and substitute these x values in the equation. So y becomes 2 times 1 plus 6. What's 2 times 1? 2 times 1 is 2, and 2 plus 6 will be 8. So this result is 8. Now we have 1, 8. Okay, this is the first step. Construct table of values and obtain the value of x and y. Okay, so this x and y forms an order pair. Okay, so those order pairs should be plotted on the Cartesian coordinate system. So in step 2, we have order pairs. Minus 1 is paired with 4, 0 is paired with 6, and 1 is paired with 8. Okay, so we plot these 3 points in the Cartesian coordinate system. So as we have seen in our previous lesson, we know how 1, 8 is pointed on the Cartesian coordinate system. Okay, this is very important to sketch the graph of any function. So 1, 8 is a point in the first quadrant because both x and y are positive. So we expect in the first quadrant or here. So where do I put this 1, 8? Count 1 unit to the right of the y-axis, and you need to count 8 above the x-axis. Okay, so you need to properly count here. So roughly 1, 8 is a point around here. Say this is 1, 8. The other point that we have obtained in the first step is 0, 6. Okay, you can take this one and go this way. No problem in which order you are taking. 0, 6. Okay. 0, 6 is a point on y-axis. Okay, we have seen what the points on each of the axes looks like. Always, if the first entry is 0, that point is on the y-axis. Okay, is it on the negative y-axis or positive y-axis? The second entry can tell us the location of the point. Since this is positive, you need to move 6 units above the x-axis. Okay, you cannot be perfect in sketching, but you can take the rough approximate position of the point. So the point 0.6 probably may be here, okay? Don't worry about its exact position, but you have to make sure that 0.6 is above the x-axis, right? So say this point is 0.6, and we have one more point, which is minus 1.4. Minus 1.4 is a point in the second quadrant, right? Because the first entry is negative and the second entry is positive. Therefore, minus 1.4 is somewhere in the second quadrant, which is 1 unit to the left of y-axis and 4 units above the x-axis. Okay, you can roughly put that point here and connect the 3 points, okay? So using these 3 points, you can construct a straight line. That straight line represents the graph of a linear function y is equal to 2x plus 6, okay? This is how we sketch the graph of a linear function using the first method that I explained, right? So I will show you the second method, but before I move to the second method, I need you to practice a certain linear function. Okay, can you try this one? Sketch the graph of y is equal to minus 3x plus 12. Clearly, this is a linear function, and I need you to follow the steps that I explained, and you need to follow the steps that I used in the first example. So I will give you a certain second to answer this thing. Can you try it? Well, I hope you properly sketched this graph. So you need to take 3 x values. You need to take 3 different x values. X is equals to minus 1, x is equals to 0, and x is equals to 1. To make the calculation easier, you can take any x values that you like. I'm just taking minus 1, 0, and 1 to make this calculation very easier so that you can easily obtain the y values. So substitute these x values and obtain the corresponding y values. Okay, whenever x is minus 1, the value of y becomes minus 3 times minus 1, which is positive 3, plus 12, the result becomes 15. Okay, for x is equals to minus 1, you have 15. And put x is equals to 0 in the equation, or substitute x is equals to 0, then this becomes minus 3 times 0 plus 12. The result becomes 9, right? And put x is equals to 1, minus 3 times 1 plus 12. The result becomes, in this case, whenever you substitute 0 in this case, the result is 12, right? Okay, but when we substitute positive 1 in this equation, the result becomes minus 3 plus 12, which is positive 9, okay? These 3 points are enough to sketch the graph of the given linear linear function. So the order pairs that we have here are minus 1, comma 15. Okay, whenever x is minus 1, y becomes 15. Whenever x is 0, y becomes 12. And whenever x becomes positive 1, the y value becomes 9. Okay, these 3 points are enough to sketch the graph of the given linear function. Okay, the second step. So these are step 1, right? These are step 1. The second step is you need to plot these 3 order pairs in the Cartesian coordinate system, right? So you all know that where the points are located, right? The first order pair is minus 1, comma 15. This point is a point in the second quadrant, 1 unit to the left of the y-axis, and 15 units above the x-axis. Okay, it is roughly somewhere in the second quadrant, right? The second point is 0, comma 12. Okay, 12 is a number below 15, so you can put it somewhere on positive y-axis, right? And the third point is 1, comma 9. Look, both the first entry and the second entry are positive. Definitely this point will be a point on the first quadrant. So this point will be somewhere in the first quadrant. Okay, so you connect these 3 points and form a straight line. That straight line represents y is equals to minus 3x plus 12. Okay, so if you have a squared paper, it's very easy for you to construct this kind of graph, right? I recommend you to use a square paper in graphing so that you can easily determine where minus 1, comma 15 is located, right? You can count 15 and put that point on the Cartesian coordinate system. Okay, this is how we use the first method to sketch the graph of a linear function. So the second method, in method 2, we only need 2 points to sketch the graph. Okay, so this method 2 is finding the x and y intercepts. Okay, in the second method, we only need 2 points, and those 2 points are the x and y intercepts, right? So how do we find the x-intercept? Okay, to find the x-intercept, we usually make y is equals to 0. Okay, always whenever you are calculating the x-intercept, you need to substitute y is equals to 0. Do you know why we are using y is equals to 0 to find the x-intercept? Well, we use y is equals to 0 to find the x-intercept because x-intercept means a point where the graph crosses the x-axis. So at every point on the x-axis, the value of y is 0. So always, whenever we calculate the x-intercept, we substitute y is equals to 0. And to find the y-intercept, we substitute x is equals to 0 in the equation, right? The y-intercept is a point where the graph crosses the y-axis. As you all know, at every point on the y-axis, the value of x is 0. So always, whenever we calculate y-intercept, we put x is equals to 0 and obtain the corresponding y-intercept. For example, sketch the graph of y is equal to x plus 4. Clearly, this is a linear function. Here, you are asked to sketch the graph of this linear function. Okay, here we will do two things, calculating the y-intercept and the x-intercept. Here, as I've said, to find the x-intercept, put y is equals to 0, and to find the y-intercept, put x is equals to 0, and obtain the required intercepts. So let's do it together. So let's say x-intercept. So let's calculate the x-intercept. To find the x-intercept, don't forget to put y is equals to 0 in the equation. So take this equation and make y is equals to 0, or substitute y is equals to 0 in the given equation. So 0 is equals to x plus 4. Now, using the knowledge that you have in grade 7, you can easily obtain the value of x. 0 is equals to x plus 4, and subtract 4 from both sides, then this becomes x plus 4 minus 4. So this is 0. So x plus 0 is x, and 0 minus 4 is minus 4. So the value of x becomes minus 4. Okay, this is the x-intercept. Okay, this is the x-intercept, or the point where the graph crosses the x-axis. Or you can put it in the form of order pair in this way. Okay, now we have the x-intercept. The next thing is calculating the y-intercept. Okay, in calculating the y-intercept, we substitute x is equals to 0 in the equation. So substitute x is equals to 0 in the equation, then the equation becomes y is equals to 0 plus 4, which is 4. Okay, so at y is equals to 4, the graph crosses the y-axis, or you can put 0, 4. Okay, now we have the x-intercept and the y-intercept. So using these 2 points, we can construct a straight line passing through these 2 points, right? So roughly the vertical line is y-axis and the horizontal line is the x-axis, okay? So x is equals to minus 4 means you need to move 4 units to the left of the y-axis. So roughly you can count 1 up to 4 and put minus 4. And the y value, or the point where the graph crosses the y-axis, is at 4. Okay, at y is equals to 4. That means you need to count 4 units above the x-axis. Probably somewhere, you get somewhere y is equals to 4 here. Now, we have those 2 points. X is equals to minus 4 and x is equals to 4. Okay, through these 2 points, you can sketch a straight line. Okay, a straight line passing through these 2. So this is the graph y is equals to x plus 4. Okay, this is the required graph. So here we see that in method 2 we only need 2 points, and in method 1 we needed 3 points. I hope you prefer to use the second method because it requires only 2 points. It requires only the x and the y intercept. So using those 2 points, you can sketch the graph. So this method is a method that I think is a time-saving method. So hopefully you prefer to use method 2. Anyways, you are free to use whatever method that you prefer to sketch. Okay, so this is the first example. Let me add one more example regarding method 2. sketch the graph of y is equal to minus 2x plus 4. Okay? This is a linear function. This is a linear function, and you are asked to sketch the graph of this function using the second method that we have seen. Okay? Don't forget to calculate how x and y intercepts are calculated, right? So the only thing that we do here is we calculate the x and the y intercept. Okay? Can you tell me what point or what number should I take to find the x-intercept? Well, if you say y is equals to 0, you are correct. So to find the x-intercept, take y is equals to 0 and substitute in the equation. So whenever we substitute y is equals to 0, the equation becomes 0 is equals to minus 2x plus 4. Okay? So finding the x-intercept requires finding the solution of this linear equation, right? So this is the same as 0 minus 4 is equal to minus 2x. Okay, you can subtract both sides minus 4. And this gives us minus 4 is equals to minus 2x. Okay, now x value can be obtained by dividing this equation both sides by minus 2. Okay, so x value becomes minus 4 over minus 2, which is positive 2. Okay, so this is the x-intercept. Or you can put this in the form of order pair 2, 0. Okay, we have one point in which the graph crosses the x-axis. The other thing is the y-intercept. Okay, can you tell me what should I do to find the y-intercept? Well, if you say x is equals to 0, take x is equals to 0, you are correct. So in the given equation, we substitute x is equals to 0, then this becomes y is equals to minus 2 times 0 plus 4. Minus 2 times 0 is 0. 0 plus 4 is 4. Okay? So this becomes 4. Okay? So the graph crosses the y-axis at positive 4. Or you can take an order pair 0, 4. Okay, now we have these 2 points so that we can sketch the graph of the given linear function. Okay, one of the point is x is 2. Okay, x is 2. And the other point is y is 4. Okay, you can roughly sketch point 4, 0, 4 somewhere here. So you connect these 2 points, okay? Through these 2 points, you can construct a straight line. So that straight line is the graph of y is equals to minus 2x plus 4, okay? So this is how you sketch the graph of a linear function. Generally speaking, the graph of a linear function is a straight line, right? So always you need to expect a straight line which is neither vertical nor horizontal. It's a kind of slopy straight line. And we have seen the 2 methods of sketching the graph of a linear function. If you remember, in the first method, we have seen how to construct a table of values and pick unordered pairs. In the second method, we have seen how to find the x and y-intercept to sketch the graph of a linear function. Okay, so this is all about our today's lesson. I hope you enjoyed the lesson. Thank you for listening.
The Philippine eagle is one of the world's largest and rarest birds of prey.